Using the square root property to solve quadratic equations. Product property for square roots. For a greater than or equal to 0 and b greater than or equal to 0, the square root of ab equals the square root of a plus the square root of b. In words, the square root of a product is the product of the square roots. Simplifying expressions with square roots. To use the product property to simplify a square root, 1. Write the radicand as the product of the largest perfect square factor and another number. 2. Apply the product property for square roots. In this example, we want to simplify the following. For a, we want to simplify the square root of 36. 36 is a perfect square, so the square root of 36 is 6. B, square root of 12. 12 is not a perfect square. However, I can rewrite 12 as the square root of 4 times the square root of 3. 4 is a perfect square, so I can take the square root of 4, which is 2. 3 is not a perfect square, so it remains under the square root. Our final answer is 2 square root 3. For part C, square root 48. For 48, that divides up into 6 times 8. 6 is 2 times 3, and 8 is 2 times 4. 2 times 3 times 2, and then I break up the 4. 2 times 2. One method to find your perfect squares is if you have a pair, you have a square. So I have one pair here with my 2's, call that pair A, and then I have another pair here with another set of 2's, we'll call that pair B, and 3 is left over by itself. So I can say with pair A, I'd have a square root of 2, with pair B, I'd have a square root of 2, and with my 3, it would stay under the radical, which would give me 4 square root of 3. Another way this problem can be worked is to try to find your largest perfect square. For this problem, that's going to be 16, and 16 times 3 is 48. The square root of 16 is 4, so I have 4 square root of 3. Either way, you still get to your final answer of 4 square root 3. Simplifying expressions with square roots. Quotient property for square roots. For a is greater than or equal to 0 and b greater than 0, the square root of a over b is equal to the square root of a divided by the square root of b. In words, the square root of a quotient is the quotient of the square roots. If a square root has a fractional radicand, we simplify the radical by writing it as an expression whose radicand is not a fraction. In this example, we want to simplify. The first one we want to simplify, part A, is the square root of 25 over 81. 25 is a perfect square, and the square root of 25 is 5. 81 is a perfect square, and the square root of 81 is 9. So my answer is 5 divided by 9. For part B, I have the square root of 7 divided by 64. 7 is not a perfect square, so it needs to stay as the square root of 7. 64 is a perfect square, and the square root of 64 is 8. So I have the square root of 7 divided by 8. Rationalizing the denominator of a radical expression. We simplify an expression of the form p divided by the square root of q by leaving no denominator as a radical expression, which is rationalizing the denominator. To rationalize the denominator of the fraction of the form p divided by the square root of q, where q is positive, we multiply the fraction by 1 in the form of the square root of q divided by the square root of q. Simplifying a radical expression. To simplify a radical expression, 1. Use the quotient property for square roots so no radicand is a fraction. 2. use the product property for square roots, so no radicand have perfect square factors other than 1. 3. Rationalize the denominators, so no denominator is a radical expression. 4. Continue applying steps 1 to 3 until the radical expression is completely simplified. In this example, we want to simplify the following. Part A is 3 divided by the square root of 7. So we want to multiply the square root of 7 by something that will give me a perfect square. When I'm multiplying by the square root of 7 divided by the square root of 7, I'm really multiplying by 1. I chose the square root of 7 because when I multiply it by the square root of 7, I should get the square root of 49. And 3 times the square root of 7 is just 3 square roots of 7. Now I can take the square root of my denominator, so I bring over 3 square root of 7, and the square root of 49 is 7. So my final answer is 3 square root of 7 divided by 7. I can't cancel here because 7 and the square root of 7 are not equal. For part B, I have the square root of 5 divided by 44. When I look at my 44, that's the same as 4 times 11. And 4 is a perfect square. The quickest way to solve this problem is by separating 44 into the square root of 4 times the square root of 11 and simplifying, then rationalizing the denominator. So we have the square root of 5 divided by the square root of 4 times the square root of 11. The square root of 4 is 2, so I have the square root of 5 divided by 2 square root of 11. Now I can focus on getting rid of the square root of 11. If I multiply the square root of 11 by the square root of 11, that will give me the square root of 121. If I multiply my bottom by the square root of 11, I have to multiply the top by the square root of 11, and since they're equal, I am only increasing my fraction by 1. The square root of 5 times the square root of 11 gives me the square root of 55. I bring my 2 over, and 11 times 11 is 121, so I have the square root of 121. Now I want to take the square root of what I can, so the square root of 121 is 11. I have the square root of 55 over 2 times 11, and 2 times 11 is 22. So my final answer is the square root of 55 divided by 22. Solving quadratic equations of the form x squared equals k, where k is greater than or equal to 0. Square root property. Let k be a non-negative constant. Then x squared equals k is equivalent to x equals plus or minus the square root of k. So what this means, if I have 4 squared, that equals 16, but I can also have a negative 4 squared, which also equals 16. So 16 equals x squared. That means that 4 can equal x, or negative 4 can equal x. I can also write this as x equals plus or minus 4. In this example, I want to solve x squared equals 18. So I'm going to start by making sure my x squared is by itself. Since it is, my next step is to take the square root of both sides. That gives me x equals plus or minus the square root of 18. 18 is really 9 times 2. I can simplify part of 18, but 18 itself is not a perfect square. So I bring over my plus or minus, the square root of 9 is 3, and then I bring over what I can't take the square root of, which is 2. So my final answer is 3 square root of 2, or negative 3 square root of 2. In this example, I want to solve 5t minus 3 equals 4. In order for the square root property to work, I need my square by itself. add 3 to both sides. 5t squared is equal to 7. Then divide both sides by 5. So t squared is equal to 7 divided by 5. And now I am ready to take the square root of each side. T equals plus or minus the square root of 7 over the square root of 5. I need to rationalize, so I want to multiply top and bottom by the square root of 5. So this equals plus or minus 7 times 5 is 35. So I have the square root of 35. 5 times 5 is 25. So I have the square root of 25, which is just 5. This cannot be simplified any further. I can also write my answer as the square root of 35 divided by 5, or negative square root of 35 divided by 5. In this example, solve, in my parentheses, x minus 6, outside my parentheses square, equals 3. So in this case, my perfect square is the parentheses. I have my square isolated already, and now I am ready to take the square root of each side. So I have x minus 6 equals plus or minus the square root of 3. When I add 6 to both sides, I cannot do math with 6 in the square root of 3. So I have x equals 6 plus or minus the square root of 3. This is the same as 6 plus the square root of 3, or 6 minus the square root of 3 as our two answers. It's standard form to write your rational number, in this case 6, first, and your irrational number, in this case the square root of 3, second. In this example, we want to solve 4x plus 7 parentheses squared equals 12. Make sure your square is isolated. Since it is, we can go ahead and take our square root. So that leaves us with 4x plus 7 equal to plus or minus the square root of 12. 12 is 4 times 3. So the square root of 12 is the square root of 4 times the square root of 3, which means I have 2 square root of 3. Now I can subtract 7 from both sides. 4x equals negative 7 plus or minus 2 square root of 3. Then we divide both sides by 4. So my final answer is x equals negative 7 plus or minus 2 square root of 3 divided by 4. In order for me to reduce this, the 7, the 2, and the 4 would have to have common factors. They don't, so this can't be reduced any further. I can also write my answer as negative 7 plus 2 square root of 3 divided by 4, or negative 7 minus 2 square root of 3 divided by 4. Imaginary numbers. Definition: imaginary unit I. The imaginary unit, written lowercase I, is the number whose square is negative 1. That is, I squared equals negative 1, and I equals the square root of negative 1. Definition of square root of a negative number. If p is a positive real number, then the square root of negative p equals I square root p. In this example, write the number in BI form, where b is a real number. Simplify the result. For part A, we have the square root of negative 9. First thing I have to do is deal with the negative. I can write the square root of negative 9 as the square root of 9 times the square root of negative 1. The square root of 9 is 3, and the square root of negative 1 is I, so my answer is 3i. For part B, we have the square root of negative 20. We know that 20 is 4 times 5, so our first step is to split everything up. We have the square root of 4 times the square root of negative 1 times the square root of 5. Then we want to take the square root of what we can. The square root of 4 is 2, the square root of negative 1 is I, and the square root of 5 comes over. An expression in the form of bi is a pure imaginary number. So the answers of 3i and 2i square root of 5 are both pure imaginary numbers. Complex number. A complex number is a number of the form a plus bi, where a and b are real numbers. Solving quadratic equations of the form x squared equals k, where k is less than 0. The square root property. Let k be a real number constant, then x squared equals k is equivalent to x equals plus or minus the square root of k. This property is still useful even when we have an imaginary answer. In this example, we want to solve x squared equals negative 49. Step 1 is to make sure our x squared is isolated. Since it is, we want to take the square root of each side. So x equals positive or negative. We know that 49 has a square root of 7, and if we have a negative sign, that means my answer is going to include an I. So my answer is 7i or negative 7i. In this example, we want to solve r squared equals negative 32. Since my r squared is isolated, our first step is to take the square root of both sides. The square root of r squared is r equals plus or minus. We know that 32 would be the square root of 16 times the square root of 2 times the square root of negative 1. So bring down r equals plus or minus. The square root of 16 is 4. Square root of 2 we don't know, and the square root of negative 1 is I. You need to write the I between the 4 and the square root of 2, since I is no longer under the radical. Anything that is no longer under the radical goes in front. So my two answers are 4i square root of 2, or my answer is negative 4i square root of 2. In this example, we want to solve x plus 5 parentheses squared equals negative 20. Since our perfect square is isolated, I can square root both sides. X plus 5 equals plus or minus. Since 20 is 4 times 5, I know that I can take the square root of 4, but not 5. So the square root of 4 is 2, and the square root of 5 I don't know. Since the 20 is negative, I also factor out an I. Since I equals the square root of negative 1. Now I can subtract 5 from both sides. So x equals negative 5 plus or minus 2i square root of 5. Negative 5 plus 2i square root of 5 is one answer. Negative 5 minus 2i square root of 5 is my other answer. In this example, solve for x minus 4 parentheses squared equals negative 81. So square root both sides. The square root of x minus 4 squared is x minus 4. Equals the square root of negative 81 is 9i, because the square root of 81 is 9 and the square root of negative 1 is I, And since we took the square root of both sides, I need to add plus or minus. Now add 4 to both sides, and x equals 4 plus or minus 9i. So my two answers are 4 plus 9i or 4 minus 9i. Using the square root property to solve quadratic equations. First, you need to feel comfortable with simplifying expressions with square roots. It's easy if our square root's a perfect square, but if it's not, you have to separate your number into the part of it that's a perfect square and the part that isn't, and simplify what you can. Part of simplifying our expressions is rationalizing the denominator of a radical expression. You multiply your fraction by whatever it will take to make a perfect square in your denominator. So if I have 1 over the square root of 7, I multiply top and bottom by the square root of 7. So I have the square root of 7 divided by the square root of 49, and I could take the square root of 49, leaving me with the square root of 7 over 7. Solving quadratic equations in the form of x squared equals k, where k is greater than or equal to 0. Take the square root of both sides, and when you take your square root of k, it's going to be plus or minus the square root of k. And then you solve as you normally would. When you're dealing with imaginary numbers, you're dealing with a negative under your square root. The square root of -1 is equal to I, so if you have the square root of -25, you can work it like the square root of 25, but because of the negative, you would have to have an I in your answer. So instead of 5, it would be 5i. Solving quadratic equations in the form of x squared equals k, where k is less than 0. The only difference in solving equations in the form of x squared equals k, where k is greater than or equal to 0, versus ones where k is less than 0. When k is less than 0, you're going to have an I in your answer. And you always write your answer in the format of your real number plus or minus your imaginary number.